video to accompany the unit conversion homework. I'm assuming that you've already done the unit conversion homework and you're just using this video as a guide to help you through a couple rough spots. That is my assumption. All right, well, let's do it. Whoops, hang on. There we go. All right, number one. Express 531 centimeters in meters, kilometers, millimeters, and nanometers. A nanometer is 1/1000th of a meter. Alright. 531 centimeters into meters. Well, I start with what I know, what I'm working with, and I set up a conversion factor, and I know that I want centimeters on the bottom and meters on the top. And I further know that there are 100 centimeters and in 1 meter. There we go. So if I perform this calculation, the centimeters will cancel out, and it's just 531 divided by 100, which means I move the decimal place 2 spots, so 5.31 meters. And there we go. Okay, in kilometers. So once again, let's start with 531 centimeters. I will begin by converting that to meters. 1 meter is 100 centimeters. And then I know that in 1 kilometer, there are 1,000 meters. So that means my centimeters cancel out. My meters cancel out. I'm only left with kilometers, which is what I wanted. So this is going to be 5.31, or 531 divided by 100, which is 5.31, divided by 1,000, which is 0.00531, or 5.31 times 10 to the minus 3 kilometers. And there we go. Millimeters. 531 centimeters. I know that there are 1,000 millimeters in a meter, and there's 100 centimeters in a meter, so there must be 10 millimeters in a centimeter. So 10 millimeters, 1 centimeter. Centimeters cancel out. 531 times 10 is 5,310. There you go. Let's see, millimeters and nanometers. All right. So 531 centimeters. A nanometer is 1/1000th of a meter. All right, well, I'm just going to go meters first then. So let's do 1 meter over 100 centimeters. And then I'll go from meters to nanometers, because I know that there are 1 billion, which is 1 times 10 to the 9 nanometers in 1 meter. So 531 divided by 100 is 5.31 times 1 times 10 to the 9 is 5.31 times 10 to the 9 nanometers. Now, as we work through these problems, let me remind you that yes, I want you to get the correct answers, but more importantly, I want to see you setting the problem up this way. This idea of being able to work with units and setting up the problem in a flowing manner that takes you from start to finish is what's going to serve you further down the road. Furthermore, when I look at your work, I want to be able to see exactly how you arrived at your answer. So just as important as getting the answer is setting it up the way I'm doing it here. All right? All right. Number 2. Omaha to Chicago is 471 miles. How long would this be in kilometers? All right, let's start with what we're working with, 471 miles. I happen to know, or you can look it up, that there are 1.6 kilometers in 1 mile. That is by no means an exact measure, so this will affect my final answer as far as significant figures go. So it's just a matter of multiplying that by that. I'll use my trusty calculator over here. 471 and 1.6 times, looks like it's 53.6, but I should only have 2 significant figures in my answer. So the final answer will be 750 kilometers. Done. Number 3. A common pain reliever contains 500 milligrams of acetaminophen per tablet. The package directions recommend taking no more than 8 tablets in a 24-hour period. How many grams of acetaminophen a day is the maximum recommended dose? All right. Well, what do we know here? We know there's 500 milligrams of acetaminophen in 1 tablet. So that's where we'll be starting, and I'm winding up with grams per day. So grams over day is where I'm going to wind up. So let's start here. 500 milligrams per tablet. So 500 milligrams per 1 tablet. Now, I further know that there is 1,000 milligrams in 1 gram. So now I've converted my milligrams to grams. Haven't done anything with the tablet yet. So if I were to stop right now, my answer would be in grams per tablet. But I want grams per day, don't I? So if we examine our problem here, we can see that no more than 8 tablets in a 24-hour period. 24 hours is 1 day, so that means that we would take 8 tablets in 1 day. So that means tablet cancels with tablet. So now I'm left with grams per day, which is what I wanted. So 500 divided by 1,000 is 0.5 times 8 is 4. So 4 grams per day. Done. Oh, done. There we go. Alright, the moon is 234,214 miles from Earth. How many quarters laid side by side would it take to span this distance? A quarter has a diameter of 2.3 centimeters. Alright, well, we're going to start with what we know here. 234,000, 214 miles. And I'm trying to get to centimeters. So I happen to know that there are 5,280 feet in 1 mile. So my miles are gone. Trying to get to centimeters still. So I further happen to know that there are 12 inches in 1 foot. My feet are now canceled out. And I further know that there are exactly 2.54 centimeters in 1 inch. Now my inches are gone. And finally, a quarter has a diameter of 2.3 centimeters. So I have one more conversion to look at here, and that would be 2.3 centimeters per 1 quarter. So now my centimeters cancel out, and I'm left with quarters, which is what I wanted. So now it's just a matter of doing the arithmetic. 2, 3, 4, 2, 1, 4. 5,280 times 12 times 2.54 times, and finally 2.3 divide. Looks like I have 16 billion 388 million 299 809.4, but we can't have 0.4 of a quarter, so it'll be that many quarters. Well, actually, I need 0.4, don't I? Yeah, hang on a minute. That's the answer right there. But I can't have 0.4 of a quarter, so to make up that last little 40% of a quarter I need there, my final answer should be 63882999810 quarters. There we go. That's the final answer. Now, a couple things. I want to remind you again, I'm interested mostly in not that you remember how many quarters it would take to get to the Earth, but that you remember how to set things up in this fashion. Units canceling out till you get your desired result. Okay? Now, if you chose to do this a different way, for instance, say you went 1.6 kilometers to meters and then down to centimeters and quarters, you might get a vastly different answer. It's going to be off by a few million, though. In fact, probably a couple 100 million, just because of the poor translation from 1.6 kilometers to 1 mile. But these are all exact. So sig fig wise, this should normally tell us that this one, which is not exact, is our answer to have two sig figs in it. But this one's a little different because these quarters are distinct items. Okay, so sig figs doesn't necessarily apply here in the most meaningful sense. So I'm going to go with that as my answer. I like that. Okay. How old will you be when you have lived exactly 1 billion seconds? I would like to think that this surprised many of you when you did this. Let's see. Now, I know that I want to convert 1 billion seconds to how old I will be, so that will be years. So let's start with 1 times 10 to the 9, which is a billion, seconds. All right. Now I'm going to start by converting that straight to minutes. So 1 minute is 60 seconds. From there, I can go from minutes to hours. So 1 hour is, what am I trying to say here? 60 minutes. So now I'm at hours. I'll go to days, because I know that there are exactly 24 hours in 1 day. Okay, so far all of these has been exact. And that number's exact because I told you it's exact, right? But here we hit a snag. Once we get to days, how do we go from days to years? Well, I'm going to do it this way. I know that 1 year is equal to 365.25 days, but wait a second. Every year we celebrate, or I say a quarter of a day goes by that we don't observe. That's why every 4 years we have a leap year where we add an extra day, because after that 4th year, 4/4 of 1 day have passed that we haven't observed. So we fix it by putting that day, that extra day in every leap year. So further, if you are old enough to have lived past the year 2000, prior to the year 2000, you may have noticed something, may not, but there was a leap year in the year 2000. Now, normally we celebrate leap years and every year is divisible by 4. So let's back up 100 years or so. There was, of course, a leap year in 1896 because 96 is divisible by 4. There was a leap year in 1904 because 1904 is divisible by 4. But there was no leap year in 1900, just as there was no leap year in 1800 and there was no leap year in 1700, even though those century years are all divisible by 4. But there was a leap year in 2000. We celebrate an extra day every 400 years. So century years do not have a leap year unless it's divisible by 400 rather than 4. So I'm going to tack another another 2.5 on the end there, and that's still not exact, but that's getting much closer to exactly to the number of days that are actually in a year. So yeah. So I'm gonna let it go at that and take that as my answer. That's gonna be pretty close. All right. So incidentally, if you were around in 2000, you celebrated a leap year that hadn't been observed in 400 years. So that's pretty exciting. All right. So 1 times 10 to the 9 divided by 60 divided by 60. I just screwed up on calculator. You can't see that, but let me retype that in. 1 times 10 to the 9 divided by 60. Boom. Divided by 60. Divided by 24. And divided by 365.2525. Pow! Okay, that comes out to 31.68787092224 blah 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 blah. But okay, we are restricted by the number of sig figs here. This is exact, that's exact, but that's not. So at most I can have 365, I can have 1, 2, 3, 4, 5, 6, 7, but that's not exact either. So at most I can have 6 sig figs, but don't worry about that. That's utterly meaningless to us. A year down to 6 decimal places. So let's just round it to 1 decimal place here. 31.7 years. And I wonder if you found that surprising, that you have to get almost 32 years old before you can live exactly 1 billion seconds. 1 billion is a huge number. Yes, indeed. All right, so there we are. Number 6. Usain Bolt runs the 100-meter dash in 9.58 seconds. How fast is this in miles per hour? I wonder if this answer surprised you as well. Because I think if you asked most people, what's the top human speed? What's the fastest a human being can run? I imagine they might say a number that's different than what this is going to turn out to be. Yeah, that's just been my experience. Okay, so we want to convert a 100-meter dash in 9.5. So right now we're in meters per second, and we want to go up to miles per hour. So right now he goes 100 meters per 9.58 seconds. All right, I'll deal with the distance first. I'm going to go to meters up to miles, and then I will deal with the time. So I want to first change this to kilometers. So there are 1,000 meters in 1 kilometer. And there are 1.6 kilometers, more or less, in 1 mile. So that takes care of my going up to miles. Now I just need miles per hour, and it's in seconds. So I'm going to go to minutes first. So there are 60 seconds in 1 minute. And there are 60 minutes in 1 hour. So now minutes cancels minutes, seconds with seconds. I'm left with miles per hour. So let's do this. 100 times 60 times 60 divided by 9.58 and divided by 1,000 and divided by 1.6. Well, look at that. That comes out to about 23. It comes out to 23.486 blah 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 blah. But I'm restricted to 2 sig figs here because of that conversion. So we're really looking at 23 miles per hour. That seems pretty slow, doesn't it? If you think about it. But that's top human speed. That's the fastest a human has run, 23 miles per hour. I mean, squirrels run faster than that. Well, there it is. All right. Speaking of animals we probably could beat in a foot race, goose. If a goose weighs 3.295 kilograms, how much does it weigh in pounds and ounces? Excellent. All right, so let's start again with what we've got here. So 3.295 kilograms. All right. Well, here's a little rhyme for you to remember. 2.2 pounds of jam is about the same as a kilogram. 2.2 pounds of jam is about the same equals a kilogram. So now that's how I remember that there are 2.2 pounds in 1 kilogram. All right. Now, this then will take me straight to pounds. So let's do that first. 3.295, 2.2 times divided by 1. So this is 7.249 pounds. All right. But I want the answer in pounds and ounces. All right. So this can also be written as 7 plus 0.249 pounds. And now there are exactly 16 ounces in a pound. So I can further write this as 7 pounds plus 0.249 pounds times 16 ounces in 1 pound. So 16 times 2.49 is 3.984. And I'm just going to round that to 4. So 7 pounds, 4 ounces. Wonderful. If you take 5 milliliters of medicine each day, how many days would 1 gallon of medicine last you? All right, seems pretty straightforward. We'll start with 1 gallon. And I had to look this up, as I'm sure you probably did. Maybe you didn't. Maybe you already knew that there were 3.79 liters in 1 gallon. Now, just like all the other metric stuff, going from liters to milliliters, that means there's 1,000 milliliters in 1 liter. So 1 liter is 1,000 milliliters. And I'm trying to get to days. So I've got to go from gallons to days, but I know then that we take 5 milliliters of medicine each day. So that means 1 day, 500 milliliters. So gallons cancels with gallons, liters with liters, milliliters with milliliters. I'm left with just days. So how many days is this? 3.79 and 1,000 times 5 divide 758 days. Number 9. Number 9. Number 9. Number 9. Number 9. Number 9. If your pace on a treadmill is 65 meters per minute, how long will it take you to walk the equivalent of 1 mile? I have no idea. Let's figure it out using unit conversion. Now I'm interested in the equivalent of 1 mile. So that's what I'm going to start with. 1 mile. Now once again, I recall that there are 1.6 kilometers in 1 mile. And furthermore, then there are 1,000 meters in 1 kilometer. And this tells me that I go 65 meters per minute. So 1 minute, 65 meters. All right, so miles are gone, kilometers are gone, meters are gone. I'm left with minutes. So let's see, 1.6, 1,000 times 65 divide comes out to 24.6 minutes, but I'm restricted to 2 significant figures here, so we'll round that up to 25 minutes. So, walking at 65 meters per minute, it would take you 25 minutes to walk a mile. All right, there we go. One milliliter of ink can print 50 pages of text. How many pages could you print with 1 quart of ink? Great honk. Well, we know that we're going to be starting with 1 quart of ink and converting that to pages of text. So let's do that. 1 quart. And again, I had to look this up. You may already know that 1 liter is equivalent to 1.06 quarts. So from 1 liter then, I can go from 1 liter to 1,000 milliliters because I know that I'm dealing with 1 milliliter of ink. And then furthermore, I know that I can do 50 pages with 1 milliliter. So my quarts are gone, my liters are gone, my milliliters are gone. I'm left with pages, which is what I want. So let's see, I've got 1,000 times 50 and 1.06 divide 1.06 divide. Looks like you could do 47,169 pages. It says 0.8, but really we're restricted to at most 3 sig figs here. But again, these are distinct items. So with 1 quart of ink, how much, depending on what you typed, could you get ink on 47,069 pages? Yeah, you probably could. So we're just going to go with that as our answer. So 47,169 pages. Yeah, the sig figs matter if something's measured or calculated. But when you're dealing with distinct items, you know, I'm not interested in half a sheet of paper. So gotta just apply some common sense there. All right. The average adult humans hold the average adult human holds about 5 liters of blood. How many cups of blood could a vampire serve from one human? Oh, well. All right. Well, let's start with 5 liters then. 5 liters of blood. And I think you will recall from a previous question that there are 1.06 quarts in 1 liter. So I've got it in quarts because I'm sure you know there are 4 cups in 1 quart. And there we go. 1.06 times 4 times, that comes out to 21.2. But this is about 5 liters, so that is certainly not exact. So we're really restricted to just one significant figure here. So we're just going to say 20 cups, 1 sig fig of blood. 20 cups of blood. All right. The screen of a laptop computer measures 8.25 inches wide by 6.25 inches tall. If this computer were being sold in Europe, what would be the dimensions of the screen in centimeters? All right, well, let's deal with the width first. .25 inches is the width. And by now you already know that there are 2.54 centimeters in 1 inch. And that is exact. So 8.25, 2.54 times, this comes out to 20.955, but I'm restricted to 3 sig figs, so this comes out to 20, well, what would that be? 21.0, 21.0 centimeters. So the width is 21.0 centimeters. Let's look at the length. The length is 6.25 inches, 6.25 inches. And again, 2.54 centimeters per 1 inch. So 6.25, 2.54 times comes out to 15.875, which, when we allow for sig figs, is going to be 15.9 centimeters. There you go. Sig fig's a little tricky on that. Rounding. Okay. We have to stop here, so we'd round up that, but rounding up that takes it to 10, which means I have to round that up. Here, we want 3 sig figs, so we have to round that up, and rounding that just takes us to 9. So we're good there. All right. If the price of gasoline is $2.539 per gallon, what is the price in cents per liter? I don't have any idea. Let's figure it out. So I've got $2.539 per 1 gallon. There we go. Now, you will recall from a previous problem that there are 3.79 liters in 1 gallon, and I completely screwed that up, didn't I? Because obviously I need the gallons on the top. So let's redo this again. $2.539 per 1 gallon. And as I was saying, we know that in 1 gallon there are 3.79 liters. So right now that would give my answer in dollars per liters. Yes. But you know what? There's a problem with this problem. Oh, no, it's not. No, it's not. We're good. We're good to go. We're good to go. Sorry. I was looking at the next problem and thought we had to count for 16 gallons, but we don't. Okay. So from here then, I can just go to cents because I know that there are exactly 100 cents in $1. Okay. 2.539, 3.79 divide 100 times 66.992, blah blah blah. But I am restricted to 3 sig figs. So I want to round that 9, but that 9 goes to 0, which causes that to go to 7. So 67.0 cents per a liter. Cents per liter. Okay. This is a problem. I was getting confused. Suppose your automobile gas tank holds 16 gallons. And the price of gasoline is $0.325 per liter. How much would it cost to fill your gas tank? All right then. Well, we can do this a couple ways here. We know that if I have $0.325 per liter, I need to find out how many dollars that is per gallon. So if I do that, that gives me, I know that there are 3.79 liters in a gallon. So 3.79 liters, 1 gallon. So that will give me dollars per gallon. So 0.325, 3.79 times. So this comes out to $1.23.175, which after sig figs is $1.23 per gallon. Now, you will recall that your tank holds 16 gallons. So 16 times 1.23. .23, 16 times, comes out to $19.68. If you kept this number in your calculator and just multiply that, you're going to be off from my answer by a few cents, but your answer is just as good. So 16, I'm getting $16. I got to round that to 3 sig figs. So I'm going to go with $19.69. $19.69. I shouldn't put. You really shouldn't put dollars and cents there. Let me do that right. $19.69. Yes. Yes. Very good. Okay. All right. Finally, I'm asking you to create and solve your own unit conversion problem. Make it interesting and challenging. So what I decided to do was see how many marbles it would take to fill my living room. My living room, LV, is 16 by 12 with 8-foot ceiling. So it is 16 feet by 12 feet by 18 feet. So that means it would have a volume of 16, 12 times 8 times 1,536 cubic feet. Remember, when you multiply these three numbers, you also have to multiply the units. Cubic feet, and volume is measured in cubic units anyway, so that makes sense. But don't forget to multiply your units. Okay, so that's the volume of my living room. Now the marble I'm using is a 1/2 inch across. A 1/2 inch across. So I've got a marble that is 1/2 inch across. That means that the radius of said marble, or the sphere, is going to be 1/4 of an inch, or 0.25. And that is a sphere, so good thing I happen to know the formula for the volume of a sphere. Volume of a sphere is equal to 4/3 pi r cubed. And in this case, r is 1/4. So that equals 4/3 pi 1/4 cubed. 1/4 is just 1/64. So let's do that. Let's say 3 divide pi times, and multiply by 1/64, so that's just divided by 64. 64 divide. All right, that comes out to 0.0654, blah, blah, blah. Carries on and on and on and on. All right, so I'm going to good. So, okay, and that is in cubic inches, because my R was in inches. Cubic inches. So now, if each marble has that volume, and my living room has that volume, then the number of marbles that can fit in my living room from floor to ceiling will be this divided by that. But hold the phone. I can't divide this by that, because this is in cubic feet and that's in cubic inches. So let's take a moment and figure out what this would be in cubic feet, or we could figure out what this would be in cubic inches. I'm going to go that way. So what would 1 cubic foot be in inches? Well, 1 cubic foot means that I have a cube that is 1 foot by 1 foot by 1 foot. Well, 1 foot, as you know, is 12 inches, so this is also 12 inches by 12 inches by 12 inches. So that means 1 cubic foot, 1 times 1 times 1, is equivalent to 12 times 12 times 12. Or 1,728 cubic inches. Inches times inches times inches. Okay, so I think I'm finally ready to go. I have 1,536 cubic feet. I'm going to convert that to cubic inches, so 1,728 cubic inches, 1 cubic foot. And I know that this is going to be 1 marble per 0.06544 blah 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 cubic inches. So now I can just do the math, can I not? Okay, I already have that number saved in my calculator. So let's do 1,536 1536, 1728, divide, and then take that result, divide it by that, divide, and I've clearly made a mistake somewhere, a colossal mistake, because I came up with 13.58 marbles, which is not correct. Oh, I must have screwed up there. Hang on. I'm not done yet. Obviously, that's going to be an enormous number. So let's do this again. 1536, 1728 times. I think I divided last time. That's what I did. All right, now 0.06544 to mine. Oh, that's a much more reasonable answer. Okay. 559,413.2. So I'm assuming then that would fill up my living room entire. So it wouldn't even take that extra little I'd need a whole marble to try and fit in that extra 20% space. So the most I can fit in here would be 40,559,413 marbles. Sheesh. Okay. Whew.